Example number 1, verifying a conditional statement. If it is raining outside, then we will practice indoors. Verify when the coach's conditional statement is true and when it is false. First things first, what I want to do is I want to highlight the hypothesis in pink and the conclusion in green. So, case number 1 we'll look at is the hypothesis is true and the conclusion is true. Hypothesis, we've always given the letter of P, and the conclusion is always given the letter of Q. So case 1 happens when it is raining. And we do practice indoors. So when P is true and Q is true, the conditional statement is true. Another way of looking at this is nothing has been broken. If it is raining and we do practice indoors, that means that it is absolutely true. It's important to think about these conditional statements as not like capital T truth. Every single time it is raining, every single team on the planet is going to practice indoors. It's just for a very small hypothesis and conclusion. So, if P is true and Q is true, then the conditional statement, or P implies Q, is true. I'm just going to flip over to the next page here. Okay, so if I were to look at this right here, if P is true and Q is true, P implies Q is true. Now this is our truth table. This is where we're going to hold all of our findings, and this is for case 1. Alright, let's go back up to case 2. Case 2 is when the hypothesis is false, so P is false, and the conclusion is false. That means it is not raining, and we do not practice indoors. You have to think about this as true as well. P implies Q is true. Nothing is broken. If it's not raining, then it doesn't, who knows what could happen. If it's not raining, it means that we don't have to practice indoors. The only rule that we've set up is that if it is raining outside, then we will practice indoors. But if it's not raining, we do not have to practice indoors. So if we were to put our findings into our truth table here, we would say that if the assumption is false, or the hypothesis is false, and it follows with a false conclusion, that still makes the conditional statement true. Case 3. Case 3 is when the hypothesis, or P, is false, and the conclusion is true. So that means that it is not raining, and we do practice indoors. There can be lots of different reasons why a practice is chosen to be held outdoors. It doesn't necessarily mean raining, but if we set up the conditional statement, it's not raining, but we do practice indoors. The conditional statement is if it's raining outside, we practice indoors. There's nothing that breaks that conditional statement in saying that we're choosing to practice indoors, even though it's not raining outside. So if P is false and Q is true, P implies Q, which is our conditional statement, is still true. So if we were to put this in our truth table, if our hypothesis is false, we start out with a false hypothesis. Hey, but the conclusion ends up following what our conditional statement said. It doesn't mean that it's false. It means that the conditional statement is still true, because ultimately nothing breaks from if it's raining, then we practice indoors. But if it's not raining, we can still practice indoors. And the last case, when the hypothesis is true, I'll say that's the conclusion. When the hypothesis is true and the conclusion is false. So the only rule we made was if it's raining, then we practice indoors. So that means that if it's raining is true, so it is raining, and we don't practice indoors, that means that P implies Q is false. Because the only rule we made up was that if it's raining, we practice indoors. But if it is raining and we don't practice indoors, that means that the conditional statement is false. So if we have a true hypothesis and a false conclusion, that's the only way for a conditional statement to be false. What's important to note here is that this is not just specific to this example. This truth table, true hypothesis leading to a true conclusion is true. A false hypothesis leading to a false conclusion is true. A false hypothesis leading to a true conclusion is true. And a true hypothesis leading to a false conclusion is false. This is universal. This works in every situation. This works in every single situation. It doesn't matter what the example is.